Form 3 syllabus as tested in Chemistry Paper 1 for the year 2020. Welcome. We begin with question number 4, which tested the topic the mole. So in part A, carbon 2 oxide was passed over 4.1 grams of heated oxide of copper. Here we expect the oxide of copper to be reduced to copper metal using the reducing agent of carbon 2 oxide. So the mass of oxide has been given here as 4.1 grams. So we were told that this oxide of copper was heated in a combustion tube until there was no further change. The question goes ahead to explain that the mass of the final substance, which in this case is copper metal, was found to be 3.29 grams. So we were asked to complete table 1 and go ahead to determine the empirical formula. Before we do that, a student should take note that when we subtract 3.29 grams from 4.1 grams, then we are able to get the mass of oxygen. So we go ahead and complete table 1 and find the empirical formula for 2 marks. Beginning with mass of copper, copper was the final substance here, so its mass was very direct at 3.29 grams. For oxygen, we need to subtract mass of copper from the mass of the oxide. So 4.1 subtract 3.29, and that gives us mass of oxygen as 0.81. A student who does this would score the first half mark. Now moving to the number of moles, this would be 3.29 for copper divided by the molar mass of 64 as given here. That is giving us 0.051 for the next half mark. Now for oxygen, we have 0.81, which we have calculated here, divided by 16. And again, we get 0.051. Now we can see that the number of moles are the same. So mole ratio is 1:1. And for that matter, our empirical formula becomes CuO for the last half mark, totaling 2 marks. In part B, we are asked to state the property of carbon 2 oxide that was demonstrated in the experiment. This is reducing property of carbon 2 oxide for 1 mark. A candidate who wrote that carbon 2 oxide is a reducing agent would also score the mark. We move on next to question number 5. Question 5 still came from Form 3, and this time the topic was Organic Chemistry 1. In part A of question 5, we are asked to draw the structural formula of 2-methyl-but2-ene. The underlying word here is structural formula. We expect a completely open structure. So because it is a butene, a candidate would go for 4 carbons in a straight line or a straight chain. Then but2-ene means the double bond is between carbon 2 and 3. From here, we are supposed to put our branch, a methyl group, on carbon number 2. Again, because it is a structure, we are supposed to fully open our methyl group. don't condense as CH3. That would not give you the mark. Because the question is clear, we want to see a fully open structure. From here, now we go ahead and put the other hydrogens to ensure all the carbons are bonded to 4 other atoms. So here we are. This would be now the complete structure for 2-methyl bute 2-ene for 1 mark. Part B, we are told that bromine water was added to what we have just drawn here. It is unsaturated, and for that matter, our yellow bromine water is expected to be decolorized. So we are asked to state the observation made, and a candidate would simply write that yellow bromine water is decolorized, which could be replaced with the word changes to colorless. Now, some things have since changed the way the examiner expects us to write the observations. One, we have been telling you that bromine water could have several shades depending on concentration. Colors like brown would be mentioned, colors like red or even orange would be mentioned. But the latest information is that only yellow will be allowable for bromine water. Next, we have always told you that you can use the word turn instead of changes to colorless. A candidate would be allowed to use the word turns to colorless. This time round, turns is taken to mean a physical change. For that matter, turning to colorless is now no longer allowable. We shall only accept the word changes. Lastly, we were asked to name the type of reaction that took place. This is addition reaction. Now, we proceed to question number 10. Question 10 still came from Form 3 work, and this time round we tested chlorine and its compounds. Question 10. When chlorine is bubbled through hot concentrated sodium hydroxide solution, the examiner was lenient enough to give us the products. Sodium chlorate 5, sodium chloride, and water are formed. What a nice examiner who goes ahead to give the product of a reaction. So what a candidate was supposed to do in part A was just to go ahead and write the equation. Products having been given. So we have chlorine gas reacting with hot and concentrated alkali in the name of sodium hydroxide. We get sodium chlorate 5 with that formula. We get sodium chloride as well, and we are told that some water will also be produced. To balancing, a 3 on chlorine, a 6 on our hot concentrated sodium hydroxide, a 5 on sodium chloride, and finally a 3 on water. The examiner went ahead to ask us in part B that sodium chlorate 5 and sodium chloride, these are two soluble salts with different solubilities in water. So the method that can be used to separate them, candidates, is what we call fractional crystallization. So the equation here, balanced with correct state symbols, would give us 1 mark, and the method of separation, another 1 mark. Lastly, for question 10, we are asked to give one use of sodium chlorate 5. Sodium chlorate 5 can be used as a herbicide We also use it as a bleaching agent. Sodium chlorate 5 can also be used in treatment of sewage. We also use this in manufacture of dyes. We also use this to make fireworks, which can also be replaced with explosives or the matches. Any one of those for 1 mark. We proceed to question 13. Question 13 tested nitrogen and its compounds. So in part A, we are told that nitrogen 4 oxide is prepared by heating lead 2 nitrate. We are asked to write an equation for the reaction. Quite easy. Lead 2 nitrate with that formula is being heated. We shall get the oxide of the metal. We shall get our nitrogen 4 oxide gas, of course with some oxygen as well, balanced with a 2 on the oxide of lead, a 4 on the gas, and a 2 on the nitrate of lead. Now part B needed some additional chemistry knowledge, which we usually give our candidates in the topic reversible reactions of Form 4. Let's have a look at question 13, part B. So in part B, we are told that at room temperature, nitrogen 4 oxide exists as an equilibrium mixture with its dimer. The gas is brown, but the dimer is yellow. And of course, the delta H, the enthalpy change for the forward reaction, is negative, meaning it is exothermic. So now we reduced the temperature by placing the mixture in an ice bath, and then we are asked to state and explain the observation. So here we need to take note that forward reaction is exothermic. It produces heat. Then the backward reaction is the opposite. It would be endothermic, which uses heat. So in this case, when you reduce the temperature of the mixture in equilibrium, the equilibrium will shift in a direction so as to increase the temperature. In our case, the equilibrium will shift to the right to produce more heat. So the observation would be that our yellow color would intensify for the first mark. Then we go ahead to explain that decrease in temperature shifts the equilibrium to the right. This can be replaced with the words favors the forward reaction. Favors the forward reaction. Why is this so? Since it is the forward reaction that is exothermic, and this would produce now more heat to try to raise the temperature that has been reduced by subjecting the mixture to an ice bath. So we've scored 1 mark by stating the observation. Explanation would score the next mark. So stating that decrease in temperature shifts the equilibrium to the right, half a mark. And forward reaction being exothermic, another half a mark, total 2. Students in Form 3, this is a very interesting topic in Form 4, which we shall learn next year. Those who are revising in Form 4, I believe this makes it even more interesting. Let's proceed to question number 17, borrowed from chlorine and its compounds again. Some Compounds such as CFCs and DDT are regarded as environmental pollutants. Give the complete name of CFCs. CFCs in full means chlorofluorocarbons, as one word for 1 mark. DDT is dichloro, then we have diphenyl, and then we have trichloro, and finally ethane. This would earn the next mark. We move on to number 19. Question number 19 is testing the mole again. 6.2 grams of phosphorus was reacted with excess oxygen to form phosphorus 5 oxide. We are asked to determine the mass of the oxide formed. In this case, we are supposed to start by writing a balanced equation for the reaction between phosphorus and excess oxygen. And the examiner has told us that we shall get phosphorus 5 oxide. So here we shall balance the equation with a 4 on our phosphorus, a 5 on oxygen, and a 2 on phosphorus 5 oxide. From here, we are supposed to use the mass given here and the relative atomic mass to calculate now our moles of phosphorus. And this would be given by 6.2, the mass given, divided by 31. This is giving us 0.2 moles of phosphorus used for the first half mark. From here, we are supposed to use mole ratio to now get moles of the oxide. And as you can see, the ratio is 4:2 or 2:1. So moles of the oxide would be moles of phosphorus divided by 2, which gives 0.1. For the next half mark, from here, we should get now the relative formula mass of our oxide. And this would be given by 31 for phosphorus multiplied by 2, added to 16 for oxygen multiplied by 5. This is giving us a figure of 142 as the relative formula mass for the next half mark. Finally, to get mass of the oxide, we would multiply the number of moles that we've gotten, which is 0.1, multiplied by the RFM, and we get 14.2 grams for the last half mark, totaling 2 marks. We end this video covering Form 3 chemistry syllabus as tested in the year 2020 by looking at question number 24. Question 24 tested the topic gas laws. So question 24, as we have just mentioned, tested gas laws, but in particular the Graham's law of diffusion, which usually has several relations. I would want to refer you to our earlier video on gas laws simplified for more information. Otherwise, let's go ahead and get the answers to question number 24. Part A. A volume of sulfur 4 oxide gas was diffused from an apparatus in 96 seconds. We are asked to calculate the time taken by an equal volume of carbon 4 oxide to diffuse under the same conditions. So because we have equal volumes of gases involved here, we would use the relation from Graham's law that time for gas A, which in this case is sulfur 4 oxide, by time for gas B, which in this case is carbon 4 oxide, should give the root of the relative molecular mass of gas A by the relative molecular mass of gas B. This only works, as we agreed earlier, if the volumes are equal. The examiner made this easy by giving us equal volume. So what remains is to put in what is given in the question in our formula. Choosing the right formula would earn ourselves the first half mark. Now, time for sulfur dioxide has been given as 96 seconds. It is time for carbon dioxide that we do not have. When we go for the relative molecular masses for sulfur dioxide, it is 32 for sulfur plus 32 for the two oxygen atoms, giving us 64. For carbon dioxide, it is 12 for carbon added to 32 for the two oxygen atoms, giving us 44. From here, we work this out mathematically. So let's square both sides. Square of 96 is 92/16. Square for time of carbon dioxide remains that, and then on this side we shall have 64 by 44. When we cross multiply and find square root, our time for carbon dioxide will be given by the root of 92/16 multiplied by 44 and then divided by 64. This is supposed to give us 79.5990 seconds as the correct answer. Let's see how we are marking. First, mark from the choice of the right relation, putting in the data from the question as per the relation, the next half mark. Then we have our answer, the last half mark. So here, the examiner who marked decided to increase the marks allocated here from 1 to 1.5, because again, as you can see, the question demanded more than 1 mark. Moving to part B, this one also was testing on gas laws, but the marks were 2. Instead, we reduced from 2 to 1.5 so that we could increase the marks for part A. Let's have a look at part B. The rate of diffusion of neon was found to be 1.45 times faster than that of an equal volume of gas X at room temperature. We are asked to determine the relative formula mass of gas X, given that the RAM, relative atomic mass of neon, is 20. So here, we would still use Graham's law, rate of diffusion of neon by rate of diffusion of gas X. This time round, we are using a different relation from the other one because we now have rate and not time. So rate of diffusion of neon by rate of diffusion of gas X should be the same as the relative molecular mass of gas X divided by the relative molecular mass of our neon. Kindly take note of the difference relation for Graham's law. And kindly visit our video on gas laws simplified. From here, we put in our data from the question. Rate of neon, we are told, is 1.45 times faster than X. So we shall let rate of diffusion of X to be 1 and that of neon to be 1.45. So 1.45 by 1 should give us the root. RMM of X is not known, but of course RAM of neon is given as 20. Moving forward, we simplify these and we have to square both sides. 1.45 square gives 2.1025, and on the right we shall have the relative formula mass of X, but let's call it RMM for now, divide by 20. When you work this out, we get RMM of X to be 20 multiplied by 2.1025. And This gives an answer of 42.05. We can approximate to be 42. When it comes to award of marks, substituting the values in the formula, half a mark, multiplication by 20, half, and final answer, half, of course without units. We've come to the end of this video where we have reviewed Form 3 chemistry syllabus as tested in the year 2020 chemistry paper 1. Thank you for being with us till now, and keep it right here for more insightful reviews.